many of you have tried learning a new language? Put your hand up. Quite a lot of you. So the way languages are taught in schools and phrase books is a method called push learning. So you're taught how to say certain things, for example, how to order tea, how to talk about the weather, how to ask for directions. But there's a whole different approach to learning called pull learning, where you learn the things that you want to learn. For example, I arrived in Riga airport last night, and maybe I want to learn how to say something in Latvian. Maybe a black backpack. Can someone volunteer to pronounce that in Latvian? Anyone? OK, thank you. Or maybe I want to learn how to say, this is a man wearing a red T-shirt. I'm not even going to attempt to pronounce that. And there are several other things that I might be interested in learning based on what I'm seeing. Wouldn't it be really cool if I could have the world around me explained in the language that I'm trying to learn? I'm here to tell you that this is possible. Now, you might be thinking, how does this have anything to do with the title of my talk? I'm here to tell you that deep learning is what makes this possible, and we can do this right in the browser. So deep learning is an approach to machine learning that uses biologically inspired neural networks, which are essentially a cascade of multiple layers of nonlinear processing units. So there's two phases to implementing a deep learning model. So the first phase is called training, where you take a network, such as this one, which has two hidden layers, and you show it a large amount of observational data. So this could be lots and lots of images of birds and dogs and cats and giraffes, or it could be text from lots of different books in the English language. And based on all this observational data, the neural network learns to extract latent insights and identify patterns in the data. So that was training. The second phase is called inference, where you show the network a completely unseen image, and it makes a prediction on that image or on that piece of text. So it's basically taking what it's learnt from the observations that you've shown it and using it to make a prediction on something that it's never seen before. So this isn't a talk about machine learning theory. This is a talk about practical applications. So over the next 20 to 30 minutes, I'm going to give you first an overview of how machine learning is currently done, and this is a server-side approach. I then want to introduce a whole new approach to machine learning, which is done entirely on the client. I'm going to talk through some of the pros and cons of each approach, and I have a really cool demo to show you of machine learning happening actually live in the browser. I'll then dive into the actual architecture of the demo that I built and show you some of the code and how you can actually implement this yourselves. And lastly, I'll leave you with a decision framework for how you can evaluate whether to run machine learning on the server or on the client. And this is probably what's going to be most useful for all of you to take away. Oh, so before I dive in, I'm Nikhila Ravi. I'm a software engineer. I did my undergrad at Cambridge. I then went and studied machine learning at Harvard, and I learned how to code at a wonderful coding school called Founders and Coders in London. So machine learning traditionally is done on the server. So a model, a neural network, is trained with all the observational data that I mentioned on the server, and the model is then hosted on the server. The client, which could be a phone, a browser, sends data to the server, which then runs it through the model and sends back predictions to the client. So that's the traditional approach. There are a couple of challenges with this implementation, and I want to focus on three of the key challenges. So the first is the infrastructure cost. So I was working on a couple of projects last year, while we were using EC2 instances on Amazon Web Services, which many of you might have used. And it was costing us $24 a day to train a model, which, as a student, it was prohibitively expensive. So if you want to run something on the server, you have to be aware of the cost required to do that. The second is the network connectivity and latency. So if your application operates in an environment in which there might be high latency, or if you depend on having really good network connection, then running something on the server might not be the best approach in case there are any connection issues. The third is the technical expertise required to actually set up a model and train it on the server. And many small companies might not have this expertise, or if you're working on something as a hobby project, it might take a lot of time for you to actually ramp up on this. But there is a lot of good news. And the good news is that end-user devices are becoming increasingly more powerful. So the decreased cost and the increased prevalence of GPUs on laptops, coupled with the introduction of JavaScript web APIs that allow access to the low-level functionality and enable hardware-accelerated graphics and computation. So, for example, access to WebAssembly allows developers to write low-level code that directly controls the computer's GPU. So basically, this is enabling end-user devices to actually become really powerful computation engines. For example, the browser can now actually execute and run inference on machine learning models, which previously wasn't at all possible. Similarly, increased computational power on end-user devices like mobile phones means that we can actually run models on the device themselves. So this is opening up the possibility of a whole new approach to machine learning that is done entirely on the client-side device. So we're now moving to a phase where any internet-capable device can run machine learning models on the device with no software installation required. So what does this new approach look like? So client-side machine learning, the two phases I talked about, training and inference, would still be split between client and server, but the training was the only part that would be done on the server, and inference would be run entirely on the client, which could be a phone or a browser. So I want to show you an example of what client-side machine learning can do. So let's take this example of image captioning. So here I have an image, and I want to generate a natural language description of what is in this image. So, for example, a man in blue shorts is jumping into a lake, and I know which lake this is exactly. So what would this involve? So image captioning requires two models. So starting with an image on the right-hand side, I want to get to a caption on the left-hand side. So pass the image through model 1, which is a model called a convolutional neural network, which basically takes the image and produces a fixed dimensional vector representation, which we call a feature vector. We then take this feature vector and pass it through another model, which has been trained on a large corpus of English language text and can be used to generate a natural language description of this image. So I'm going to show you now a demo of image captioning happening live in the browser. Okay. So I have Instagram open here to I don't know if you can see this. How do I show my browser page?
It was just more there.
Oh, okay.
Yeah.
Perfect. Thank you. All right. So I have Instagram open to one of my favorite food accounts, because I like looking at food pictures. And as I refresh the page, you probably saw these little analyze buttons show up. When I click on one of these, I can generate a description of this image and also a translation of that image into a different language. So in this case, it's going to be translated into Spanish. So what's happening is that the image is being taken from the web page, being run through the model in the browser itself, which is generating this text, and then the text is then being displayed on the screen. So what does it say? It says, a piece of cake on a white plate. It's pretty good. And then I can look at these individual words as well. Maybe you can try a different account. So here I have hashtag DevTernity. I was just trying this out earlier. So let's try this on another image, maybe this one. Oh, let's try this one. So again, the image is being processed live in the browser. We're generating a caption and displaying that next to the image. So a group of people standing next to each other. So it's a bit vague, but pretty accurate. Anything else? Maybe this one. Let's see what it thinks. And so this is running as a Chrome extension in the browser in Chrome. This says a man standing in front of a TV. So all of them have been reasonably good and generate a fairly interesting description of the image, which is also being translated into a different language. All right, let's go back to the slides. Unless anyone wants to volunteer their Instagram, and we can try it on your photos. No? OK. All right. So that was a pretty cool demo. Did you guys like it? So you might be thinking, so now you've seen it work. You're probably wondering, how does it work? And how can I build something like this myself? So behind the scenes, this uses a library called WebDNN, which has two components, a Python API and a JavaScript API. And WebDNN essentially takes models written in Python, optimizes them to run in the browser. So you can run inference in the browser. So the Python API is called a graph transpiler, and this takes a model written in any Python framework like Keras or Chainer and converts it into a format that can be run in the browser. The JavaScript API of WebDNN converts this into a web-compatible format and actually runs it in the browser. So this is an architecture overview of the Chrome extension and also of the model and how it's running. So on the right-hand side, you can see the model itself, and on the left-hand side is actually the Chrome extension. And I'm going to talk you through every step of this process and give you some code snippets to show how it's actually implemented. So step one, take a model defined in Python and convert it into a format compatible for the web. So this involves taking the network definition, which is similar to the slide I showed you at the beginning, where you could see the different layers. That can be represented as something called a network definition, which you can take and then convert it into a JSON format. Then you have to also take the weights, which are the output from training the model itself. And when you have both of these, you can then actually run the model in the browser using the JavaScript API. So the WebDNN Python API is acting as a transpiler and outputs these two outputs these two files and optimized parameters and the model graph descriptor. So this is the only Python slide in this whole presentation. Everything else is completely in JavaScript. This is basically showing the two steps required to convert a model in Python into a web-compatible format. So you can see there's one line called Keras converter, which does a conversion, and another line, the generate descriptor, which actually generates the graphed definition of the network. Okay, step 2 is actually loading the model in the browser. This uses the WebDNN JavaScript API and loads the model definition from the JSON file and the optimized parameters, and runs it in the browser. So once the model is loaded, we can then use it in any of our browser-based applications. So how does the model actually run in the browser? So we're using one of several web APIs. This could be WebGL, WebAssembly, or WebGPU. Now, WebGPU is only supported on a limited number of browsers, and the application that I showed you uses WebAssembly, which is supported in Chrome. All right. Loading the model into the browser is as simple as including the webdnn.js file in your HTML file. The run model.js file is what actually has the code which we're using to load the images and get the description. So the main thing that you want to look at is just how simple it is to include this into your application. So loading the models has 2 steps in our case because there's 2 models that we're using. So the first, run image, uses the image captioning model, and the second, run caption, is loading the image captioning model. And the last step encapsulates both of these into a caption generator function, which we can easily call, and it runs both those steps sequentially. So the second step is actually running inference. So once we have an image that's in a vectorized format, and once we have an image and we want to generate the caption, we want to be able to call this function and be able to very easily retrieve a caption for that image. So this runs the first model, which extracts image features, which is the vectorized representation. We then take the image features and pass them into generate caption from image feature, which gets us the caption that we're interested in. So the last step is encapsulating this into a Chrome extension. So the first 2 steps that I talked about, so transpiling and running the model in the browser, are applicable to any browser-based machine learning application. There are some intricacies with a Chrome extension that I want to highlight because they're very interesting, and Chrome extension actually makes it very easy to do something like this. So in a Chrome extension, who's built a Chrome extension first? I'll get an idea. So a couple of people. OK, so Chrome extension has 2 components. One is a background script, and the other is a content script. So the background script is running continuously in the background, and this is where our machine learning model is going to be running, because we want it to always be running and ready to receive an input. The second part is the content script, which is injected into every tab that is opened. And Chrome extensions have a really interesting message passing API that enables you to communicate between the background script and the content script. So this is the right-hand side shows you the content script, and the left-hand side shows you the background script. And I'm going to talk you through how the message passing works. So on the content script side, when a user clicks on an image, so you saw the little analyze buttons. So when someone clicks on one of those, the content script sends the image to the background script with a message of run model. In the background script, when it receives a message telling it to run the model, it will query for which was the active tab, get the image, and call the function run. So now run is a function that takes the image and passes it through both the models and gives us the output caption. So once the caption's been generated, the background script then sends the captions back to the content script. So it uses a tab ID to identify which of the tabs to send it back to. And then the content script is listening for this message, and we can add a listener, which can then get the caption back to the content script on the content side and actually display it in the browser. So it's quite a nice way of communicating between the two and having the model continuously running. So you don't have to launch a new instance of the model for every tab. OK, so that was sort of a broad introduction to machine learning in the browser, how to actually set up and implement a Chrome extension to do image captioning. But there is so much more that you can do with client-side machine learning. And this is really being enabled by a number of JavaScript libraries, including WebDNN, and most recently, TensorFlow.js, which started off as DeepLearn.js and then evolved into TensorFlow.js, and a number of other libraries as well. And image captioning is just one of the many different models that you can use. So there's now pre-trained models for pose detection, for image classification, sentiment classification, style transfer. The host of possibilities is now bigger than ever. I just want to quickly highlight TensorFlow.js, which was launched in March 2018, so very recently. And they have great documentation and a lot of examples of code that you can actually do. And one of the most interesting things about TensorFlow.js is that they have an API that allows you to actually create new models directly in the browser. And what I was talking about before of having training on the server and inference on the client, we can now actually do both directly on the client, which is opening up so many more possibilities for how we do machine learning. And interestingly, it also has node.js binding, so you can actually use the same code in the browser and in node.js. So what's best for your needs? So how many of you like to try working on side projects in machine learning or use machine learning in your jobs? Put your hands up. Quite a few of you. OK, so it depends really. So depending on the size of your company, whether you're doing it as a side project, you might have to face a trade-off between server-side or client-side machine learning. And I want to give you a couple of things that you should consider when making that decision. So the first is functionality and model size. So the browser is only suitable for certain types of models. So if you have a really heavyweight model, the browser isn't going to be powerful enough to run inference on it or even train it. It's probably going to be very slow to train a model in the browser. The second is device and browser compatibility. So as I mentioned, not all browsers support WebGP or WebAssembly. You have to think about what end-user device most of your users are going to be using and whether implementing something on the client side would make sense for that application. The third is connectivity. So if your application requires high network connectivity, so you want to ensure that there's no latency, then maybe implementing something on the client would actually make a lot more sense than implementing something on the server. The fifth is speed. So this is also, I missed out cost. So I highlighted cost earlier when talking about server-side machine learning, and that it can be prohibitively expensive if you're working on something on your own or at a small company. And client-side machine learning is essentially free because your clients are the ones that are doing the computations for you. If $24 a day isn't an issue for you, then maybe it's not actually worth investing in client-side machine learning, and running something on the server will do its job just fine for you. And the last two I want to highlight are data privacy and source code privacy. So data privacy, obviously, is a really big issue at the moment. And client-side machine learning really makes this a lot easier because you don't have to send any of your user data back to your server. Everything is done on the client. And if this is really important for your users of your application, then this could actually sway your decision a lot towards client-side machine learning. source code privacy is interesting because when you have a model that's in the browser, then anyone can look at it by just going to the developer console, and it doesn't protect the intellectual property of your model. So if you're not worried about that and you're using something that's a well-known model and something that's already pre-trained, and you're not concerned about that, then that's not an issue. But if you have something that's proprietary and you've invested a lot in developing, then this might not be such a good idea. So that was a very, very quick overview of the differences between client-side and server-side machine learning. And I want to take you back to the beginning, when I was talking about my idea of an app that can describe the world to you in the language that you're trying to learn. And I mentioned this app because this really started my journey into researching client-side machine learning and really understanding and building a demo to make it a reality for myself. So I want to play this video for you of this app that actually, in real time, describes scenes as you're viewing them. So enjoy. Oh no, is it playing? So I really encourage you to go and try it out. If you have any questions, you can ask me on Slack or on Twitter. But I really hope you feel empowered to go and build your own ideas using machine learning in the browser. So I think we have time for questions. If anyone has questions.
Let's start with Slack.
Pardon?
Let's start with Slack.
Slack, OK.
There are like 2 questions. One of them is a very long one, but let's start with the short one. Is
Okay.
it possible to use machine learning models in the browser without installing custom extensions?
Yes. So do you mean custom, like, software? Yeah, so the Chrome extension was just an example of how to implement something for other people to use. That's not a website. But yes, you don't have to install anything in order to be able to do.
Okay. The second question, the long one. Don't you think that the statement client-side machine learning is just a buzzword in your case? The actual machine learning is about mathematical learning from the data, meaning the expensive training process, which actually done at the server. In your case, it's just apply around the model on the client side, so no actual learning in the browser except the feature extraction. If we remove the buzzword, should we call it usage of machine learning in the browser?
Yes, I think that's an equally good explanation. I think I want to highlight that a lot of the training is still done on the server, and client-side machine learning simply refers to the process of doing inference on the client. So he's right, or she is right, whoever asked that question, and there is no real learning happening, but with the introduction of TensorFlow.js, you can actually do learning in the browser in real time, and this offers a lot of possibilities to customize things to your client. So I think client-side machine learning is still a fair description of what it is.
All right. Right now, let's take some questions from the audience.
Yeah.
Let's imagine that you train 1,000 different networks on client mobiles. How you will merge this in one network? Possible to gather the results in one network?
So it depends what you're trying to do. If you're trying to personalize something to a user, then you wouldn't really want to aggregate it. And if you're trying to preserve someone's privacy, then you wouldn't want to aggregate. You wouldn't want to, collect all the information from many different users. But if you want to train in a distributed way, which we call federated learning, then you can just send back gradient updates, which we can then combine and update one global model on the server, and then send the updates back to all the different clients. Is that what you're referring to? Kind of learning across many different users and then aggregating the results. It is doable. I'm not sure how to do it with the current application, with the sort of JavaScript API, but it is possible. Yes.
Speaking about running it just in the client, how much JavaScript do I have to load? I have no idea how heavy the computation is, but I feel like then I have to load a megabyte of JavaScript to make it happen. Or how much is it? Because when I want to run it on this phone, it might be fine, but on a low-end device, probably not so much.
I'm not sure about the exact size, but I know with TensorFlow.js, a lot of it is very optimized. With the WebDNN framework I was showing you, it's about a year old, so it's not as well optimized. But the idea is to make it as lightweight as possible. So I'd refer you to the TensorFlow website to look at the sizes. Yeah. Anyone else?
Let's assume you have a 1 gigabyte big model on server side. When you translate it to use on browser or mobile phone, how large would it be? Would it be able to load it at all? Or it would lose something?
Yeah, you would definitely lose some accuracy, and because you'd have to reduce the model size. So that's something that you have to be willing to accept, is some reduction in accuracy. We wouldn't be able to. I doubt you would be able to preserve the accuracy of such a large model when you optimize it to run on the client. So if accuracy is really important, then that would probably be a consideration in favoring server-side machine learning.
Outside of your example, do you have any other, what's the most interesting other example you've seen of its usage so far?
Yeah, so I saw a really interesting one on TensorFlow.js where you can play a video game by training the controls to recognize any object. So instead of having to press the arrow keys, you can just say show the water bottle to move right or another object to move left. And you train the model directly in the browser to use whatever action that you want to show it. So that was really interesting as a way of teaching.
Any other questions?
Yes. Did you actually have to write your own image feature extraction code as well, or there are libraries?
There are libraries. They used a pre-trained model for both feature extraction as well as captioning. So it was actually very straightforward. Didn't have to do any training.
There is one more question in the Slack.
Okay.
Does the WebDNN Python to node.js transpiler actually use hardware acceleration, for example, the bonus chip on iPhones?
Do you mean to run inference or to do the transpilation?
I mean, maybe the author of the question can explain.
To run inference. Hi, and thanks for that. I imagine if it uses hardware acceleration to run the inference, most modern mobile phones have it, like Bionic chip, or Google also has something for
Okay, I'm not completely sure about that.
Just the metrics operation. Okay, okay.
Any other questions? Yeah, feel free to tweet or send more messages on Slack if you have questions. But
Then thank you very much.
yeah, thanks very much.